Okay, here's the third type of exercise in section 7.1. It's proofs. You construct a proof when you are given an argument. It will always be a valid argument. You're given the premises on numbered lines. For example, here 1, 2, 3, and 4 premises. And then you're given the conclusion, which is placed here and separated by a slash. And your task is to show that the conclusion follows from those premises. So you have to take a number of steps that allows you to produce if G then E, to sort of extract, if you will, if G then E from the information that you have, the 4 premises that you have. So how do you do that? You use the rules and you take one step at a time. And if you just keep going, in the end, you will be able to extract if G then E from those 4 premises. Your starting point will be to, that's the same exercise, to arrange the premises on 4 numbered lines. And then you want to write down the conclusion here on the side just to remind yourself that that's what you're shooting for. And you will know that you have achieved your goal if down here at some point you can enter a line that is properly justified. So you don't just enter that line, but you give a justification for that line. And that line is if G then E. At that point, you stop because you have accomplished the proof. So you have to start moving. You have lines 1, 2, 3, and 4. Is there something you can do? Is there some place where you can go? And basically, you have to ask yourself, do I have an opportunity to use any of these rules on 2 of the lines that I have? So your next step, step 5, would be a situation where you take 2 of these lines, 2 of these previous lines, either 1 and 2, or 1 and 3, or 1 and 4, or 2 and 3, or 2 and 1, any 2 of those, and you put them together in a way that exemplifies one of these patterns. Because if you can do that, you can infer a further formula that you can then enter into the proof. So ask yourself, for example, could I use disjunctive syllogism? Do I have a disjunction and then the negation of the first element of that disjunction? Immediately you can see that you don't. There are no disjunctions here, so you won't be using disjunctive syllogism. But what about up here? Can I do a modus ponens? Do I have a conditional? Yeah, I've got conditionals. And do I have another line that is the same as the antecedent of a conditional that I have? And if you look, you'll see immediately that you do. You have a conditional on line 1, if P then if G then T. And then on another line, you have the antecedent of that conditional, P. So these 2 lines go together in accordance with modus ponens. The antecedent is P. The consequent is if G then T. So from if P then G then T, if P then if G then T, and P, you can infer if G then T by lines 1, 3, modus ponens. So what do I do for step 6? The same thing. Now I have 5 lines, so I've got more material to work with. But the principles are the same. I just look for 2 lines that I can put together in one of these 4 ways. Obviously, disjunctive syllogism will not be an option, again, because I don't have a disjunction anywhere. I may just go back to the top and ask myself, just to try this out, Do I have a conditional, and do I have another line that is the same as the antecedent? And again, here, if you look, you'll be able to see that there's almost like a repeat of the previous situation. You have a conditional, if Q, then if T, then E. And then you have the antecedent, for, on a separate line. So again, from the conditional and the antecedent, you can infer the consequent, which is if T, then E in this case. So you enter if T, then E, and you justify it by line 2 for modus ponens, because again, that's the rule that you used. Okay, and now you do it again. See if you can find two lines chosen from any combination of 1, 2, 3, 4, 5, and 6 that will go together in accordance with one of these patterns. And sometimes you're lucky that the lines that you need to use end up close to each other. Look at lines 5 and 6. These two lines are exactly in the pattern of hypothetical syllogism. Remember, that's the rule that allows you to infer a third conditional from two conditionals that are related in a particular way. The consequent of one of the two conditionals is the same as the antecedent of the other. And then you can make a beeline from R to B here and make a conditional that says if R then B. So up here you have if G then T and if T then E, same pattern. T is the consequent of the first conditional and the antecedent of the second. So you can make that beeline from G to E in this case. So you will infer if G then E by lines 5 and 6, hypothetical syllogism. And as you can see, you're done, because you were supposed to infer if G then E, and you have. So this proof has been successfully accomplished. All the proofs in section 7.1, and actually all the proofs in chapter 7 are like that. You're given your premises, you have to reach the conclusion, and you have to take a series of bounds on the way. And each bound is an application of one of the rules, where you will be putting together previous formulae, apply the rule, sort of crank the handle, and get something out of those lines.